Good afternoon to all. I welcome you all to Day 3 International FDP. It's my great pleasure to introduce Professor A. Salama, Dean, Higher Institute of Business and Computer Science, Arish, Egypt. He has completed his PhD in Tanta University, Egypt. He received his doctorate degree in science in mathematics and computer science from CBI, International Center for Academic Research, Texas. He is a founder of Neutrosophic topological space and also Neutrosophic crisp theory in mathematics, computer science, and many applications. He is founding member of the first referred scientific journal in America and also Neutrosophic sets and systems. He has published 135 research articles in both national and international, and he receives many awards for excellence in research and academic. Today we have a very good eminent person for this international FDP. I welcome you all once again, and also Professor Salama. Thank you.
Fine. Next thing, when a die is thrown on a sand, then it may show either 6 or 5. We cannot come to a conclusion with that. Fine. Now this is what the idea of Neutrosophic about. Next, Professor Salama will be just telling you more about Neutrosophic sets. Now I'll just come to what are the application it is having for a Neutrosophic set. It is applied in many different subjects like psychology, sociology, civil engineering, information technology, and also in linguistics. Similarly, it is also applied in mathematics too, in various branches of mathematics like probability, calculus, algebra, topology, graph theory, decision making, and many more. I have been given you glimpse about the application of Neutrosophic sets. Yeah, this is what I'm just taking only 5 minutes time. Only last one is you can just go to the website of Professor Salama. This is the home page. I'll just post it in the chat box too. You can just go visit his web page, and also journal link also given. You can see this now. Click on the web page. At a web page, click on. Okay, you can see the web page if you. Yeah, this is the web page of Professor Salama. Here we can see all the works, everything. So these are the works related to Neutrosophic set theory in the web page of Laurentine. Then the journal he has, that also we can visualize. So anybody interested in this topic, it is a well good topic. You can just work in it. This is the journal web page. So this is a Scopus Index journal, and it is also cited in Web of Science. Okay, thank you so much for patient listening. Now we'll just have the introduction about Professor Salama by Ms. Kartika. Dear participants, for any questions, please mail Dr. Salama, and the mail ID I'll just post in the chat box, because due to some net problem he has left. Due to some network issue, he could not come again. I'll just post his mail ID. This is the mail ID of Dr. Salama. You can just post the things. Feedback link, I'll post it now.
Federal Parole.
Good evening to all. We come to end of this session. So on behalf of our department, so I do vote of thanks. So Dr. Salama explained about Neutrosophic sets.
شلون هذا راني
Neutrosophic sets and applications of Neutrosophic sets. Applications in the area of Neutrosophic database, image processing,
لعيبه خصني لابي
GIS topology,
نديرها في الزوم انت ما عرفتش لها.
etc. So these concepts are very interesting. He explained the concept interestingly, and I think these applications are new to us. So thank you, sir. Thank you for giving this type of concepts to us. And also, he explained about the implementation of Neutrosophic sets using OOPS concept. And this is also a very interesting one. Thank you, sir. Next one, I thank the participants for the entire session, for their patience listening. Thank you all. I thank our department people
ما عرفتش هذا
for their support. And also I should thank our convener, Dr. M. Parimala, to conduct this type of FTBs. And I thank our management also for supporting us to conduct this type of FTPs. Thank you one and all. And the feedback session, sorry, a feedback link is posted in the chat box, and you can send your feedback. And tomorrow's session, the same time from 2:30 to 3:30. And you can access the same link before 15 minutes tomorrow. Thank you one and all.
If you want to share anything, you can just share it.
سكسي هي.
Yeah.
Yes, sir.
ما عرفتش كيفاش ندير.
Professor Said Brahmi, what, sir, you can just tell me. Sir, if you want to say something, you can tell, sir. Professor?
Hi, buddy. You hear me?
Yeah, sir. We can hear.
Yes. I hope you hear me without noise. I hope to thanks Dr. Salama for the presentation and the information on here Neutrosophic recipe set. For the researcher need more information, they can refer to the website of NSS and EGNS. And many articles and books on Neutrosophic are available on the website. For the next day, I mean tomorrow, Dr. Adesina and Madeline will give us other concepts related to Neutrosophic group theory, Neutrosophic structure theory, ideal polygroup brain theory. I also thank you, Barry, for the organization. I hope that Dr. Salama share his exploitable slide to Neutrosophic logic. And finally, if possible, that Dr. Salama explain briefly the next last slide on Neutrosophic logic gates. Thanks, Dr. Salama.
Thank you, Professor. Thank you for your kind words. Thank you, everyone. Now let us wind up the session. Meet you tomorrow. Thank you.
Neutrosophic philosophy. So I would not want to, deal with all that because the Professor Salama yesterday, of course, now.
Hello everyone. Hope you're feeling good. The researchers, ladies and gentlemen, greeting from the depth of sentimental. I don't know where to start. I hope the words help me. The words and the phrases dwindle, but I will try as best I can and hoping that the more satisfactory. I am glad to be with you in this scientific meeting and the wonderful staff in the world. My name is Ahmed Salama, Professor of Mathematics and Computer Science, Faculty of Science, Port Said University, and Dean of the Higher Institute of Business and Computer Science, Arish, Egypt. And today I will talk in my presentation about Neutrosophic, mathematics and computer science. I hope you will like it. In real life problems, the data associated are often imprecise or non-deterministic. Since the world is full of indeterminacy, the Neutrosophic found their place into contemporary research. Indeterminacy is different from randomness. Indeterminacy can be caused by physical space, materials, and type of construction, by item involved in the space, or by other factors. Neutrosophy has been introduced by Samarnadaka as a new branch of philosophy. In 1995, Samarnadaki defined the notion of Neutrosophic sets, which is a generalization of fuzzy sets and deterministic fuzzy set. Samarnadaki first introduced the notion Neutrosophic set by fusing a three-component set and the non-standard analysis. A Neutrosophic set consists of three functions where every function's value is a real standard or non-standard subset of the non-standard unit interval. In 2015, Salama and Samarnadaki were introduced the Neutrosophic crisp set theory and many applications in mathematics, computer science, information system. Neutrosophic approaches are suitable to modeling problems with uncertainty, indeterminacy, and incomplete information, in which human knowledge is necessary and human evaluation is needed. Neutrosophic set is capable of dealing with uncertainty, indeterminacy, and incomplete information. Neutrosophic set approaches are suitable to modeling problems with uncertainty and indeterminacy information, in which human knowledge is necessary. Neutrosophic set means development many applications. Neutrosophic set, Neutrosophic logic, Neutrosophic probability, Neutrosophic statistics, Neutrosophic measures, Neutrosophic calculus, and so on are gaining significant attention in solving many real life problems that involve uncertainty, impreciseness, incompleteness, and indeterminacy. In the past years, the fields of Neutrosophics have been extended and applied various fields such as artificial intelligence, data mining, software computing, decision making in incomplete, indeterminate information system, image processing, medical, biomedical engineering, economics, social science, and practical achievements. The first example, or the first application, the Neutrosophic concept of Neutrosophic topological, the concept of Neutrosophic topological space. In 2010, I am introduced the Neutrosophic topological space by using the Neutrosophic, two types of Neutrosophic topological space. The first type, Neutrosophic topological space from Neutrosophic fuzzy set. And second type, Neutrosophic topological space by using Neutrosophic crisp set, Neutrosophic crisp topological space. Some Neutrosophic concepts have been investigated by me we was developed an Excel package to be utilized for calculating Neutrosophic data and analyze them by using object-oriented programming techniques and concepts of they may apply to the design and development a new framework to implement Neutrosophic data operation. Since then, many authors have studied various aspects of Neutrosophic set from different points of view. For example, in order to apply the Neutrosophic idea to logic, we obtained a good applications in cluster analysis and image processing by using Neutrosophic domain. Promi and Rafif, Promi, Rafif al-Habib, and Florentine Samarnadaki introduced many concepts of Neutrosophic applications. The concepts of rough Neutrosophic sets, we introduced the Neutrosophic, for example, the Neutrosophic, rough Neutrosophic sets. The rough Neutrosophic sets handled incomplete and indeterminate. Handled incomplete and indeterminate information and studied some operations and their properties. The theory of classical statistics assumes a crisp, certain and clear observation parameters in technology applications. However, in such technology applications, due to their complex function, it may not possible to obtain clear or crisp values of certain parameters, so there is a chance of obtaining indeterminate, imprecise, and incomplete parameters. Neutrosophic statistics can be applied, Neutrosophic statistics applied, which is the generalization of the classical statistic. This is reduced to classical statistics when no parameters are found to be indeterminate, imprecise, or incomplete in actual practice.